Welcome all of you to the next lecture on the same what is rectilinear motion. So wherein you will be studying motion under gravity. Now already I have come across equations of rectilinear motion. So these are your v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2 as. So when body is under motion, gravity, when it is subjected to gravity, so your acceleration will be, the acceleration acting on the body will be g. So whose value is 9.81, which you are already familiar with. So now when you modify, see now before that, when you take a simple example, say when a particle is thrown up, it will not continue to move with the same velocity. So the velocity will go on reducing. The velocity will go on reducing. That is because of acceleration due to gravity. So which is minus g, we call it as the reduction in velocity. So that is deceleration. So which we take it as minus g, 9.81 meter per second square. So similarly, when you drop a particle from at certain height. So now when you with the initial velocity of 0 meter per second, so now as it moves towards the ground, your velocity will go on increasing. So it means your velocity is increasing, that is again because of acceleration due to gravity, which we take it as plus g. So now this you should remember. So whenever we are solving problems, so whenever a particle is thrown upward, your acceleration has to be minus g, rather you call it as deceleration, minus g, and whenever particle is reaching towards the ground, your acceleration has to be plus g. Now taking into these your acceleration due to gravity as g, now rewriting these your equations of motions, we will be getting as v is equal to u plus gt, v is equal to u plus gt, s is equal to half ut plus half gt square, and next v square is equal to u square plus 2 gs. Now you can observe whenever particle is thrown vertically upward or dropped downward, so it follows again rectilinear motion. Again it follows rectilinear motion. So that is why we have applied the same equations of rectilinear motion, instead replacing a with g. Instead replacing a with g. That is the only change here. And one more important thing to be noted down here is, so now when your particle is moving up, we take it as minus g. When particle is coming down, your value of g has to be substituted as plus g. I hope this is clear. Now quickly taking up a simple problem. A body dropped from 50 meter height of a building to reach ground surface. Full stop. Calculate the time required to reach the ground and velocity of the particle just before reaching the ground. Now what it says, there is a building of height 50 meter. There is a building of height 50 meter from which a particle is dropped. From which a particle is dropped. Now you are asked to calculate what is time. What is time so that the particle reaches the ground from top of the building. What is the time taken by the particle to reach the ground from top of the building? And same time you are also asked to calculate how much is the velocity of the particle just before reaching the ground. That is final velocity. Velocity of the particle just before reaching the ground. So now things are very simple. I'll quickly brief fast. So now a particle, it is dropped. So when it is say it is dropped, so it means its initial velocity will be 0. When we say a particle is dropped, it means it is at rest. So which means your initial velocity of the particle will be 0 meter per second. And same time when it is dropped, so now it it reaches towards the ground. It reaches towards the ground. It means your acceleration, whenever particle is reaching towards the ground, your acceleration has to be taken as plus 9.81 meter per second square. Now before reaching the ground, your building height is told to be 50 meters. Before reaching the ground, it travels a distance of 50 meters. It travels a distance of 50 meters. Now using those basic equation, you are asked to calculate what? The time required by the particle to reach from top of the building to the ground, and as well as velocity just before reaching the ground. Now again we are using those same basic equation. So s is equal to ut plus half gt square. So now s will be the 50 meter distance traveled. Initial velocity I have told it as 0. This entire term becomes 0 plus 1 by 2 into, this is plus, you have to be careful. what is that? The particle is from, what is that? It is reaching towards the ground. It means it is a positive acceleration. Your g will be plus 9.81 into t square. T square is the one you have to calculate. So now this term becomes 0 and you simplify. So you will be getting the value of t as 3.19 seconds. Maybe quickly you can cross check, or you can write down or cross check later. So now particle takes how much? 3.19 seconds to reach the ground from a height of 50 meter of the building. Now we have calculated how much is the time taken by the particle. So now we are also asked to calculate velocity of the particle just before reaching the ground. Velocity of the particle just before reaching the ground. So now again we are using the expression v is equal to u plus gt. V is equal to u plus gt. Yeah. So now v is the one which you have to calculate. Again initial velocity is 0. So now again g has to be plus 9.81 into t is how much? 3.19 seconds. So which you will be getting it as 31.29 meter per second. This will be the final velocity of the particle just before collision with the ground. See what problem says. So this is the ground surface. This is the ground surface. So particle is thrown vertically upward from the ground. So now say there is a particle at ground level. So I'll write ground level. It is thrown vertically upward. A particle is thrown vertically upward with an initial velocity of, so initial velocity 60 meter per second. So now particle is thrown vertically upward with an initial velocity of 60 meter per second. Now, so now once the particle is thrown upward, what happens? So it continues to move upward, now reaches maximum or the peak height, reaches the maximum or peak height, which I'll call it as say h or s, which I call it as say maximum height or peak height, which I call it as either h or s. So once it reaches the maximum height, so the velocity reached will be 0. So velocity reached will be 0. Now once it reaches the peak point, so thereafter particle will start returning to the ground. Particle will start returning to the ground. Hope this part is clear now. What is that is happening? A particle from the ground is thrown vertically upward with an initial velocity of 60 meter per second. Now once it is thrown vertically upward, it follows a rectilinear motion, reaches the maximum or the peak value, which I'll call it as say h or s. Once it reaches the peak value, it starts returning to the ground. So now this is the data given to us. Now what is that you are asked to calculate? Calculate time taken by the particle when it is 10 meter above the ground. 10 meter above the ground while returning. So now there can be two cases. So now it can be 10 meter while moving upward, or it can be 10 meter while moving downward. But you are asked to calculate time taken by the particle when thrown from the ground, reaching the peak value while returning just before reaching the ground 10 meter above the ground. You have to calculate time from ground to reach peak value, and while returning back 10 meter above the ground level, you have to calculate what is the time taken by the particle. Time taken by the particle while returning. What is that? 10 meter above the ground level while returning after reaching maximum position, and also velocity 10 meter above the ground level, and also you are asked to calculate what velocity at this position. You are also asked to calculate velocity at this position. Now what we'll do, we'll split up this problem into two parts. The first part is while the particle is thrown from the ground and reaching the peak value, we'll calculate what is the time taken by the particle from the ground to reach the value, and also we will calculate what is the distance it reaches, or the peak value it has traveled to reach the peak distance or the peak point. Clear? And that we call it as, and the corresponding time we call it as say T1. Hope this is clear. So what we have done here, we have split up the the motion of the particle into two portions. One is from ground to peak value, and the second half will be from peak to the ground. From peak to the ground. Now looking for the first half, so what is that? Motion of particle from ground to peak. Motion of the particle from ground to peak. This is the first part. So now we'll calculate how much is the time required from the ground to reach the peak point, and also how much is the distance travels to reach that peak position. Now when it is, now what problem says, from the ground it is thrown with the initial velocity of 60 meter per second. So your initial velocity will be 60 meter per seconds. Now same time, so when it is moving up, when the particle is moving up, we know that your acceleration due to gravity has to be minus 9.81 meter per second square. Your acceleration due to gravity has to be minus 9.81 meter per second square. And also we know that, so now as it progresses up, when it reaches the peak value, it reaches a velocity of, it will be in a state of rest, so that your final velocity reached will be 0. At peak, your final velocity reached will be 0 meter per seconds. So now these will be the data for the first motion. So now using again your basic equation, V is equal to U plus GT, V is equal to U plus GT. V final velocity will be 0, U is 60, and G, you have to be careful here, you have to take minus 9.81 into T. Now T being the time taken by the particle from the ground to the peak value, which I call it as T1, which we call it as T1. So when you simplify, so you will be getting T1 is equal to, quickly you can cross check with your calculator and get me the answer. You can read 60 divided by 9.81. 60 divided by 9.81. Now probably I feel 6.11 seconds should be the correct answer. So now moving ahead, now what we have calculated is the time taken by the particle from the ground to reach the peak value. From the ground to reach the peak value, and which requires 6.11 seconds. Now also what we'll do now, we'll calculate how much distance it has traveled to reach the peak point. How much distance from the ground it has traveled to reach the peak value. So now again we are using that basic expression, S is equal to ut plus half gt square. Now S is the distance you have to calculate, S or h, the vertical distance which you have to calculate. So u again 60, initial velocity is 60, so time we have calculated, which will be T1 here, so into 6.11 into, sorry, this has to be plus 1 by 2 into again G. So now again it has to be minus 9.1. We are looking, what is that, the portion wherein the body is moving or the particle is moving from ground to the peak. Your G has to be minus 9.81 again into T 6.11 square. So with that, quickly calculate the value of S and get the answer fast, which has to be in meters. Now check this answer, somewhere near 183.49 meters. So now what we have done now? So now we have taken motion of the particle from ground to peak now, which takes 6.11 seconds. From ground to peak, which has taken 6.11 seconds, and the distance traveled is 183.49. 183.49. So now the next portion. So next portion is from peak to ground. But we are not asked from peak to ground, but we are asked just 10 meters before reaching the ground. We are asked to calculate what? The time and the distance just 10 meters before reaching the ground. So now see, when it has already traveled a distance of 183.49 meters from the ground, to reach the ground back, it has to travel the same distance back. So when it has traveled a distance of 183.49 from the ground, now to reach the ground back, it has to travel the same distance. But you are asked to calculate the datas, whatever given, whatever asked to calculate are just before, 10 meters before reaching the ground. Now 10 meters before reaching the ground, in the sense, whatever 183.49 minus 10. So now this distance, you are asked to calculate datas for this distance. You are asked to calculate data for this distance. Now this distance has to be 10 meter before reaching the ground. 10 meter before reaching the ground, which will be 183.49 minus 10, which I will call it as, say, the distance y, which I'll call it as a distance y. So now your distance y, sorry, taking the second part. Now speaking of second, what is that? Second part, motion from peak to 10 meter before ground. Motion from peak to 10 meter before the ground. Now what is the peak distance we have? From ground to peak, what is the distance we have? 183.49. Now to reach back the ground, it has to travel the same distance. But you are asked to calculate what? 10 meters before this distance. Now that distance y will be, now 10 meters before the ground will be 183.49 minus 10 meter, which will be 173.49 meters. For this, what we'll do, we'll calculate how much is the time required. From, what is that? From peak to this value, we'll calculate how much is the time required. Now while returning back, it starts from rest again. While returning from the peak value, it starts from rest. Now here, you will have new set of values. While returning, your initial velocity becomes what? 0 meter per second. Now this you have to be careful. Reaches peak value, it will be in a state of rest. Clear? So when it is in a state of rest, before returning back, it will be in a state of rest. When it is in a state of rest, your initial velocity at the peak will be 0 meter per second. While returning back towards the ground, we know that your acceleration due to gravity has to be plus 9.81 meter per second square. Plus 9.81 meter per second square. Yeah. So now what we'll do? We'll calculate how much is the time required now. We'll calculate how much is the time required from peak to this value. Clear? So now we have to use here again basic equation. V is equal to U plus GT. V is equal, sorry. No, we cannot use this expression. Can we use this? V is 0. No, we cannot use this expression. I'm sorry. You have to use S is equal to UT plus half it square. S is equal to UT plus half GT square. S is equal to UT plus half GT square. So now this distance, this time I'll call it as T2. From peak to what? From peak to, what is that? 10 meter before the ground, which I'll call it as what? T2. So which I'll rewrite it as T2. Yeah. And this distance will be how much? Y. While returning back, we are speaking of this distance, which I'll call it as what? Y. Which we will call it as Y. Now quickly substituting all the values. Y is how much we have told? 173.49. 173.49. So initial velocity is 0. This term becomes 0 plus 1 by 2 into. So now body is reaching towards the ground. We know that acceleration has to be plus 9.81 into T2 square. Now only the unknown in this expression is T2, and quickly you have to solve for T2 and get me the answer. 5.94 seconds. Yeah. Now there are two times now. One is T1 6.11 second, other one is T2 5.94 seconds. Now what was T1? Time taken by the particle from the ground to reach peak value. And what is T2? Time taken by the particle from peak to just before 10 meter from the ground. Now your total time taken by the particle from the ground to reach peak and return back will be T1 plus T2, which has to be T1 plus T2. So now that is total time T1 plus T2. So that is 6.11 plus 5.94 seconds. 5.94 seconds. Yeah. 12.05 seconds. So you should be getting it as 12.05 seconds. Now what is this total time? Time taken by the particle from the ground to reach the peak value and return back just 10 meter before the ground. So we have to add up both the times, t1 and t2. So you will be getting it as 12.05 seconds. And what else you are asked to calculate? You are also asked to calculate, so velocity at 10 meter above the ground level. So while returning back again, you are asked to calculate velocity 10 meter above the ground level. Now for that you have to use again the same basic equation. Velocity is equal to u plus gt. Velocity will be u plus gt. Now again for this you have to take, what is that? The second part of the motion from peak to 10 meter before reaching the ground. So now v is the one which you have to calculate, and initial velocity is 0. Initial velocity is 0 plus 9.81 into t2. It has to be t2. Now we are speaking of the second part of the motion from peak to 10 meter before reaching the ground, which has taken how much? 5.94 seconds. With that you should be able to get the value of velocity of the particle at 10 meter just before reaching the ground. Now get this value also fast. So you should be getting somewhere near 58.34 seconds. 27 whatever, somewhere near 58.3 seconds. Okay, no issues. Whatever your answers are. So many are getting the correct answer. Now quickly to brief fast, so we are not diverting anything away from these basic equation. V is equal to u plus gt, or S is equal to ut plus half at square, or v square minus u square is equal to 2as. We are using the same basic equation. So only change is that your acceleration is replaced by acceleration due to gravity, that is g. So g has to be plus when your particle is returning towards the ground, and g has to be minus when your particle is moving away from the ground. So this is the only change here. So rest all remains. Any of such type problems can be solved.